Okay, everybody, let's look at homework 5-6, modules 5 and 6 homework. This one's a little bit weird. It's probably took you a little bit to do it. It's broken up into two parts here. The first question is what we covered in module 5, and the second question is what we did in module 6-ish a little bit. So they're fairly different. And if you weren't familiar with how to do regressions, or how to code data, two of the things you would need to do. There was this video here for how to code data. You probably had to go do some of the video watching in the module to learn about regressions. So let me just jump right in here and show you how I did it. But first we're going to need this MEPS data. This is the one we did from homework 3 in the code book. I went ahead and downloaded those already. This is the MEPS data. And then we got the code book right here. And the question is saying for the first one here, we need to run a regression. We need to predict the annual out-of-pocket expenditures for a person. And these are the things we need to include: their education, if they have private insurance, and then what their total payments are. Okay. And this is giving you just a little hint here. The education should be categorical. This one is giving you a tip on how to group the data. I actually didn't follow this at all when I did mine, so I'll show you mine slightly different. And it actually does make a fairly big difference here. So let's go look at it right away. And then there's a few other parts to number 1. So let's go look at it. So the first thing I wanted to point out is you needed to install the data analysis pack. If you haven't already done that, I just wanted to go show you really quickly how to go do that. I'm going to start opening a new Excel. And you probably can't see all that. Let me shrink this down here. So depending on the version of Excel you have, this is what mine looks like. This is Office 365, but it's probably going to be similar for other ones. You got to go to this option somehow. I just did File Options. It might be somewhere different for you. You want to go to the add-ins. You want to go look for this Analysis Tool Pack. And then you want to hit Go to install it. And then you want to make sure you click this first one right here, just say okay, and I've already got it installed. But when you're ready to access it, you go to data, and then you have this thing right here called data analysis, and that gives you the option to do a whole bunch of more fancy things than Excel can do on its own. One of them is regression, so you can just click that and start going. So make sure you've done that first. The second thing you're going to need to do is to pick which columns of data you want, and then you got to code that data into something that's going to be computable. So let's first figure out what data we want. I guess I actually struggled with this a little bit. So we have the has private insurance. That's pretty easy. Let's go see. That's not it. Let's see. There we go. So it's HI private. That's just, you want to go make sure that you're either getting a 0 or a 1. So you might want to go convert some of this data to either to yes or a no. Code that data, I should say. So we're going to go copy the HI private data, and then we're going to code it so either a yes is a 1 and a no is a 0, and all the rest should also be a 0. So that's the first thing we would need to do. Then we need to go get the expected total payments. Oops, wrong one. And for that one, let's go look at, I think it's expected total. Yep, so expected total is just a number, how much we're expected to pay. It's also important to know that what we're trying to predict here is out of pocket. So we're trying to predict this expected self-pay. So it's going to be useful to pull over both of these. So the expected total and the expected self-pay columns, because this is the one we're predicting, the self-pay. And then education. So education is where it actually gets tricky. I chose to do it differently than the instructions gave, mostly because I I just went ahead and did the work. I didn't read all of his notes here. So yours might look slightly different, but I will show you. I did it both ways, and I can show you what the result will be if you followed his route versus my route. But you'll see they're going to be vaguely similar. So you got to figure out which education you're going to use. We have lots of choices here. How you want to code it. We got education right here, and you get these sort of codes. And then we have education year, which you could also use in code. Looks a little bit less useful because we need to know if you have a master's or a doctorate or whatever, and this just stops at 5 years. So the education year is probably out, but we could use just what is education. And perhaps a better one might be this highest degree completed. This one looks pretty simple, might fit the bill. Yeah. Okay, so I used the education. I used this one. So when you see me doing my work, I use this one. And I did not chunk it into the same buckets that he's suggesting we do here. He is saying you want a no degree, the GED and diploma, a bachelor's, a master's, or a doctorate, or all others. And so I didn't do that. I did it slightly differently. So I'm going to go show you. I've pulled all this data over into this tab. And again, I'm using education year, private insurance. And then I started coding this data. And that's what that video was over here, showing you how to do that, this video right here. So if you're not familiar with that, go ahead and do that. The whole point of it is we need to get something that's computable. A 12 or a 17 or an 8 or 6 doesn't really mean anything. You know, to the statistics, to the formulas we're going to be using. So we need to sort of pull it out and differentiate. And see, I did a little bit different. I said if you had less than high school, associates, bachelor's, masters, a professional, so there's like some MDs or dentists, if you had a PhD. So I put them in slightly different buckets, and that actually does make a bit of a difference in the totals and how we're able to predict. And then this one is the insurance being normalized because again it's a 1 for no and a 2 for yes, but I wanted a 1 for yes and a 0 for no. So I went ahead and did that, and these are the formulas just like we've done this whole time, right? You can do an if or a nested if or ifs. So that's all these are. All these are the same, right? We know that if you are a professional, the code is 602, and if you have it, we put a 1, otherwise we put a 0. Likewise with the insurance. You have it or you don't. Okay. Pulled over the expected total. This is the total health insurance paid for a year. Then this is the value we're trying to predict, is the self-pay, meaning how much are you paying out of pocket. So I put this over here also just to show, to see how well we are doing at predicting-ish. Okay. So these are the pieces of data we're looking for. Okay. And so we need to run a regression. I'm going to do it again just to show you, or just to show you can see where you do it at here. Let me. Okay, so we got to go to data. Hang on. I don't think it's capturing my whole window here. Okay, so we got to go to the data analysis, regression. Okay, so y is the variable that we're trying to predict. Okay, and then x are the variables we're trying to use to figure out, or to try to find the relationships to predict that value. So we go pick this one. Here's what we're trying to predict. Is this? Come on. Okay, so we got all of that we're trying to predict. And then the variables we're trying to use to account for the prediction are all of these. So we'll grab that, pull it down. went too far. 101. There we go. Okay, and then I included the labels because that's what I selected all the way up there in the top. And then I want to just output it right here. And that's about it. So I said okay. And then here's the output. So I just want to show you that's how I got it. I'm going to go ahead and delete this though now so we can look at the one I already did, which is this guy right here. So here's the output. There is a video listed in the module 5 that video, really useful video. Another guy was talking about what regression analysis are and what all the variables mean. He has a whole series. He had 3 different videos. I ended up watching all of them. They're pretty good. So if you want to know what most of these things that you're seeing are, go watch those videos. They're really helpful. But what we care about are the R square or the adjusted R square, either one. R square is going to be a number between 0 and 1. And the closer to 1 it is, that means the better we're accounting for, better the model is able to predict and account for all the data that it's seen. Or if you're predicting, or if you're imagining those videos from the module 5, the guy who describes it, it's the line between the data points, how well it's able to account for the error above and below that line. And so this isn't doing a super great job. We're getting roughly 11 or 12, 13%, something like that, however you want to round it, of the data is being accounted for in this model, which is not great. So that's all we care about up here. Nothing super interesting right here, but this is what we do care about. We care about building a formula for how we can calculate and predict this data. So to predict this data, we need to use these coefficients. He was mentioning here in the homework to use a constant. Where was it? Right here, constant. So the constant is going to be your intercept. So here's your intercept. That's your constant. I put them out right here also. If you weren't sure, the constant is your intercept. You can see I'm pointing down right there. And then if you have less than high school, that's this guy. So since these are all ones or zeros, or all these orangish yellowish ones are going to be 1 or 0, you can only, these are all mutually exclusive. You can only have one of these things. And then you're going to have 1 or 0 of these things. And then you're going to have this expected total times by this guy, the expected total. And so you're going to come up with a whole equation, a whole formula. I can show you what that looks like. It would be something like this plus this times this plus this times that. And you would go through and do that for all of them. I didn't do it at all, but that's how you would build the equation. So it's going to be 433.58 plus minus 365.2 times either the 1 or 0 plus minus 238.84 times either the 1 or the 0. And you're going to go through all of these to make your equation. So it's going to have 8 or 9 or 10 variables in there to make your whole equation for your regression model to predict a value. And just looking over here, one of the questions was, are all 3 variables significant? And if you don't know what is meant by significance, it's pretty much any p-value less than 0.05. And this one's close, but it's not. That's our intercept. That doesn't matter. That's not one of our variables. 0.05. So this one's close, but not. This one is definitely the normalized insurance. This one's really, because that's saying you have 21 spots to the left. So that one's a huge one. So these 2 are the only 2 that have any amount of significance in our model. Let's see what the other question was. Okay, and then we want to predict the out-of-pocket expenditures for someone who has a bachelor's degree, private health insurance, and they're paying $10,000. So now that we have all this information, we can do the prediction. And I got it right here. And you can see the whole thing. It's not a big deal, but it's, so we have to take our constant plus our bachelor's degree, 'cause that's what he said in the thing. We have someone has a bachelor's degree, plus they have private insurance, plus they spent $10,000 in their expected totals there. So this one I come up with about $1,100, and that's a little bit high. Again, that's because of the way I chose to group the education levels. These are different than what was asked of you in the problem. If you actually followed, I did this after I already read that, just to see how different it would be. And so if you actually followed and grouped the education as he suggested, and you used the same codes that he did, instead of getting 1,100, you're going to get around 815. So you'd probably see 815 right here if you did it the way he predicted. But honestly, there's a lot of variation here, right? You saw we could have used several different classifiers and groupers for education. So you should get somewhere between $800 and $1,100, depending on how you did it. And I'm not going to be a stickler about that when I'm grading. As long as I can see that you're normalizing those codes, and you're running a regression analysis and you're using an equation, it doesn't really matter to me if you get the exact right answer, just as long as you're in the sort of ballpark here. But I did notice when I ran it differently, so I had mine, how you see here, and then I did it a second time, which you don't see here, using his education things. These things were identical. So the coefficients for the normalized insurance was the same, is about 304. And then the coefficient for the expected total was the same at 0.033. So if you see those two things, they should be matching on yours, and then you'll know you did that right. And then these other ones, again, there's a little bit of wiggle room in how you coded them. Okay. So hopefully that explains how we predict, using a regression model, how we predict some things like that, right? You want to come up with scenarios like he just did here, and then come up with some sort of answer. Part D is saying add 2 more variables. So it's saying go out to the maps data, go grab 2 other variables that you think might have a predictive value, and then rerun the regression analysis. I did not do that. I'm not super interested in doing that, but you get the idea. You can go add in 2 more columns, put that data over here, and then just change or rerun your regression analysis and include those 2 new columns, and just see how it does. Maybe you do better. Maybe instead of covering 10 or 12%, you cover, I don't know, 14 or 15% of the data. Maybe it's better. Not quite sure. Depends on what you choose. Might do a better job. And it might have an effect on your out-of-pocket, right? So if you're accounting for more of that data, 12 or 15%, then it might do a better job of predicting. So instead of saying 815, it might say 801 or 910. It's hard to say. But I also, so before we move on to the next one, I just want to show you, I did put a column out here with the same formula, the predictive value that we did here to get this 1100 or 815. I went and wrote the same formula and just applied it to each row specifically, and just ran it down. So you can see how close we were or were not from actual out-of-pocket versus what we predicted you should be. And you can see it's all over the place. And again, that's what I was saying. This model isn't super great. We're only accounting for 11 or 12% of the data, right? So this person actually spent $23. We predicted they should be about 200. So not, I don't know, this guy was 36 versus 70. That's not terrible. But there's some pretty big swings, right? 130 versus 677. That's a pretty big difference. 1400 versus, that's almost a factor of 10. So it's all over the place. And then let's go look at the last question. Was it number 2? This is just more your opinion more than it is a right or wrong answer. It's saying, suppose you work at a local clinic, you want to make a patient satisfaction survey, you need to pick an outcome you want to focus on, come up with the 5 most important questions you would ask. I'll show you just a couple of examples from students of past semesters. I didn't come up with these were from past semesters. But here's a couple. Right, if you're going to come up with a survey about patient satisfaction or something, You could say something like, are the hours of our clinic convenient for you? Are we responding to you properly and timely? Are the locations good? Whatever. We're going to get more specific here. Do you feel the doctor did a thorough exam, gave you enough of time in the room with them, or whatever? There's not a right or wrong answer, just looking that you have 5 of those that make sense. And that's it.